Hey everyone! Today we will be synthesizing aspirin. How exciting! With Jared! So, first what we've done is prepare a water bath using a hot plate to heat 200 milliliters of tap water in a 400 milliliter beaker. We've also placed a bottle of deionized water in an ice bath by filling a beaker half with ice and half with tap water. We've also weighed out approximately 3 grams of salicylic acid and placed it into a 125 milliliter Erlenmeyer flask. To be exact, the mass of the salicylic acid was 3.041 grams. Next, in the hood, we'll add 6 milliliters of acetic anhydride using a dropper pipette to the flask. Next, we'll add 8 drops of concentrated sulfuric acid using the dropper pipette provided. Reminder that these chemicals are very corrosive, so that's why you see that Jared is wearing gloves. You will then swirl the flask to mix all the contents gently. Should be okay. Next, we'll heat the reaction mixture in a warm water bath for 10 minutes while swirling occasionally. First, we'll check the temperature of the warm water bath to see if it is around 80 to 90 degrees Celsius. About 80 something. Nice. Notice that we have the flask suspended in the hot water using a clamp to evenly heat the mixture. While we're waiting on our aspirin mixture to heat, we'll start part 2, formation of methyl salicylate. We'll start by getting a medium-sized test tube and adding 6 drops of methanol. Okay. Next, we will add an amount of salicylic acid equivalent to the size of a head of a match, about 0.1 grams. Then we'll add 1 drop of concentrated sulfuric acid. Okay. Then we'll use a test tube holder to hold a sample in a boiling hot water bath for a few minutes. We've now noticed that all of our salicylic acid has dissolved in the hot water bath, so we will set it aside to cool to room temperature. We'll heat our methyl salicylate tube in the hot water for a few minutes. After heating for a few minutes, we will add 15 drops, approximately 15 drops of water to our test tube. It's gonna be difficult. That's fine, that's fine.
That was probably like 30, right?
Yeah, and then we're gonna cautiously smell the product. And Jared's gonna tell us what it smells like.
Mmm. Mmm. Like wintergreen.
Okay, is that your final answer?
Wintergreen.
Wintergreen, everybody. Write that in your notebooks. While we're waiting for our aspirin mixture to cool, we've weighed a dry wash glass, and the mass of that is 32.238 grams. Once our flask has gotten to room temperature, we will put it in an ice bath to speed up cooling. You can see here Jared is scraping the bottom of his flask with a stir rod, which can induce crystallization. You can see that after stirring, crystals start to form after scraping the bottom of the flask. So now we will add 40 milliliters of the cold DI water to the flask. We'll then stir for several minutes to break up any clumps of crystals and place back into the ice bath to cool a little bit more. After cooling in the ice bath for a few more minutes, we will now use a vacuum filtration setup to filter out the crystals. Remember that you squirt some water on the filter and filter paper to secure the paper onto the funnel. And the vacuum is on, so our liquid is coming down. We'll then wash the crystals with some more cold DI water. It's important that this water is cold, otherwise we may dissolve the crystals that we just made. Yeah, then we'll keep the vacuum on for a few minutes to let these crystals dry, and then reweigh them on the wash glass to determine the mass of the aspirin that we made. Now that our aspirin has dried, we will scrape the contents onto the wash glass. Note that there may still be some stuck on the filter paper, some is still in the filter itself, and some has splattered onto the counter. So those could be possible sources of error when calculating your yields. Now we will weigh the wash glass with the aspirin. And the mass of this is 38.527 grams. You can use this mass in the mass of the wash glass to then calculate the mass of aspirin obtained. To calculate the theoretical yield, you'll need this mass of salicylic acid that you started with. And once you've found the theoretical yield, you can then find the percent yield to determine how well the experiment was done. Alright everybody, so we're going to recrystallize the aspirin that we just made. Well, yeah. So to do this, we're warming up some ethanol and some water on a hot plate. They look the same. So first, we're gonna dissolve the crude aspirin in a minimum amount of warm ethanol in a 150 ml beaker. Then we'll place back on the hot plate to continue heating for a few more minutes. While it's heating, you'll add warm water drop-wise until the solution becomes cloudy. Now that our solution has become cloudy, we will set it on the hot pad in the back of our hood and let cool, and we will cover it with a watch glass, which is over there. Nice. We're going to perform the ferric chloride test on 5 different samples. We have 6 tubes here. The first 2 are for the crude and the recrystallized aspirin. The next 3 are the commercial aspirin, the salicylic acid, and the pure acetyl salicylic acid. And the last one is just a blank. So in these tubes we have 20 drops of ethanol and 1 drop of the ferric chloride. So the first thing that we're going to do is our crude aspirin. So we still have some left on the wash glass. So Jared's just going to take a tiny pinch and put that in the crude test tube. And we're going to swirl that and see what the color change is.
Ooh.
Uh-oh. So that turns purple. So note in your notebook that the crude aspirin turned purple during the ferric chloride test.
Like grape Jolly Rancher.
Yeah, it does look like really purple. Cool. So we'll skip the recrystallize for right now. And then we will do the commercial aspirin. This is just aspirin that you buy at the store. And that will go in this tube. And let's see if it changes. So, did not change color. So that's good. Note that the commercial aspirin did not change color in the ferric chloride test. Next is pure salicylic acid. So, as expected, the salicylic acid turned purple in this ferric chloride test. And the last one that we'll do is pure acetyl salicylic acid, which is what aspirin is technically called. So that'll go in the last or the 5th one. Alright. And that one did not change color either, so that one remained yellow. So the acetyl salicylic acid is still yellow along with the commercial aspirin, and the salicylic acid turned purple, and we can compare with our blank to tell the colors. And we will do our recrystallize in a moment once we have our recrystallized aspirin. We've started to see some crystals forming, so we have put our solution in the ice bath. You can see these nice crystals.
Well,
I think so. Wow, look at that. Oh.
I think we're ready to cut.
Yep. So we've been cooling some DI water in this ice bath. And now we're going to do vacuum filtration to filter out the crystals using the ice water. Do you have filter for me?
Yeah, I would.
Okay. So here's our vacuum filtration setup, and we're going to wet the filter so it sticks. You can see that in the vacuum filtration flask, there is some what seems like solid particles in there. So that could be because maybe our water wasn't cold enough, so some of it could have dissolved while we were filtering. So make sure you account for that when talking about possible errors in the experiment and things like that. So we have filtered, and now we're going to put the recrystallized aspirin on a watch glass. And so the mass of that watch glass was 40.052 grams. And so Jared is putting our recrystallized aspirin onto a watch glass. Ooh. You can see it looks a lot more white than the crude aspirin, a lot flakier. So we're going to weigh that. So the mass of the watch glass in our recrystallized aspirin is 41.766 grams. So you can subtract off the mass of the watch glass from the mass of both of them to find the mass of the purified aspirin. So now that we have some recrystallized aspirin, we're going to do our ferric chloride test with just a tiny amount to see if the color is going to change. Oh no!
It changed, but it's not nearly as intense.
Yeah, so you can see on the left, that's our crude aspirin. On the right is our recrystallized. So you can see the recrystallized is a little less purple than the crude.